In terms of threats, a lot of people are asking whether or not the clinicians actually want this, and then also looking at security privacy issues. So in terms of whether clinicians want it, they want systems they can interact with. They don't just want devices that are black boxes that go bing. This gives them the environment that they can implement nationally, can implement gold standards, but also have the ability to have a flexible approach to a certain patient and changing certain things. It gives them meaningful real-time alerts as opposed to just devices that go bing when one individual threshold gets breached. In terms of security and privacy, I think it surprises people a lot that we have data crossing the border from the United States. My answer to that was our research lead there is the chair of pediatrics, and he said, make it happen. And when you have that support, it happens. And we de-identify patients when the data leaves the hospital. They keep a translation table in the hospital.
Any additional questions? One I had is, where does this go beyond critical care?
I think we were discussing it earlier.
Brief on there, but where do you see your project specifically? Within the neonatal?
We're actually branching out in a number of areas. So beyond just looking at other areas of critical care, we have other medical devices and other conditions. So I spoke a little bit about the spells research that we're doing. We've just started doing the research on how babies are reacting to painful experiences, so when they have a needle prick, or even the routine care of changing the diaper. There's a lot of situations where the blood oxygen saturations fall when they change the baby's diaper, because when they lift them up, it goes like this and they can't breathe. So there's a lot of things, and we have a number of clinical researchers now who are wanting to perform their own studies in the environment, so it's being used for what our intention was.
John, thank you very much. So it sort of dawned on me when Carolyn was showing the population of Australia that everybody was kind of gathered on the east coast there, and you overlaid it on Canada. If you just take it at that 45 degrees, we're all lined up against the U.S. border, so another similarity. Thank you. So our final presenter this afternoon is Pierre Lemieux, sorry. So you knew I was going to do that, didn't you? Pierre is president and CTO of Calgary Scientific. He's the former CTO of Autodesk Inc.'s infrastructure division, where he helped grow the business to a $200 million enterprise. He has over 15 years of experience. Leading engineering teams, in addition to his executive responsibility as president of Calgary Scientific. Lemieux acts as CTO, managing an extensive patent portfolio, and he was a contributor to the 2002 USA CTO Summit and participated in panels for infrastructure mapping and GIS at URSA and HIDA conferences. Join me in welcoming Pierre.
Thank you very much, Peter. I want to, first of all, just set the stage in terms of who Calgary Scientific is, because that allows actually to get a good idea of what we're trying to bring to the market. And so we started Calgary Scientific 8 years ago, and the idea behind the company is that we were finding really valuable innovations being generated at the University of Calgary, but there really wasn't a good path to market for that technology. And we didn't just want to give it to the big vendors who would basically not do something very practical with it. And so we started Calgary Scientific to take that and build a channel where we could bring it out to the market. And you can see with the partners we have listed there, we've been very successful at doing that. And we're still working very aggressively at extending a channel where really innovative technology developed here in Alberta can be brought on a global basis. Where we started, and one of the things we saw when we started with the company, is that if we weren't innovative, we would not break into the medical space. And what we found is that the medical space was slow in adopting web technology, and when iPads and iPhones first came out, very slow in adopting that technology as well. And that's where we really pounced on the market, and we brought technology to market that would allow images to be brought through the web and onto mobile devices, and specifically in acute situations, to really bring value to that technology into the industry. And my team's been not scared to kind of take really tough challenges on, and as a result of that, we've got some very good technology that we're bringing out of market. what I want to share with you today is some of our experiences around cloud. And we've got some practical experience in terms of working with some of our partners who are taking technology, or actually bringing to market real cloud technologies for distributing medical images. But just to make sure we're all on the same page in terms of what that means, I'm going to just bring us back a few years. So, some of the trends is X-rays now moved from film to digital. And we've got CT scanners who create DICOM images. I'll talk about that in a moment. Those scanners are becoming better. We can generate faster images, more images per second, and you can still give patients less dose. MRIs, they're working on the protocols to make them faster to be able to make an image of the heart, to complete the heart in one pass. And all that technology basically results in more and more imaging every day. So how big exactly is this data? Well, it ranges quite a bit depending on the modality and the way that the data is stored inside of the imaging files. But you can see very quickly here, ultrasounds range from 0.5 meg to 80 megs. Can be one slice of an ultrasound, or if it's an echo where they're trying to see what's happening over time, it can be up to 100 images or more. Digital X-rays can be small or big depending on the type of capture device, and also depending on, again, what part of the body that they're capturing, they'll take more or less images. Where we're really focused on is CT and MR, and their images are basically, MR can be 256 by 256 up to 512 by 512 in terms of pixel sizes. CTs are standard on 512 by 512 pixels, but it can be as few as 20 or 30 images in a CT up to 1,000 or more. So when you look at what that means then for a hospital or a clinic who's trying to store data, that can be quite a bit of information. In terms of an imaging clinic that's doing about 50,000 studies a year, they can generate up to 30 terabytes of data. If you look at hospitals that are 100 beds, 100 to 300 beds, that number simply scales up. And that's every year more and more images being captured and generated for them to manage. Most of the scanners today create what we call DICOM files, and I heard that mentioned in a couple of the presentations, so it seems like that's pretty common. But basically it's a common representation of the medical imaging data. And what has developed over the last 20 years is systems called PACS that can store that data. It's basically, PACS is basically a medical imaging database, very simple. And initially, the PACSs that were created only stored data that came from a certain scanner. So General Electric created as PACS that could store data from their scanner. Same with Siemens and so on. But what happened is people were saying, well, that doesn't really work very well because we want to be able to store data from multiple scanners all in the same place. And so we ended up with a really good competitive landscape in terms of multiple people creating PACS, and because there's more and more data being stored. That led to what people call vendor-neutral archives, because they didn't want to buy, hospitals didn't want to buy their PACS from GE anymore because they're already buying their scanners and they want to get some distance from those manufacturers. So, and you also started to get a lot of consolidation in the industry. A hospital buying other hospitals, and they would have multiple different PACSs, and those PACSs wouldn't talk to each other. So that led to vendor-neutral archives. And basically they consolidate the data from multiple PACS, and not only do they consolidate the medical imaging data, but they also consolidate other data, EEGs, lab reports, and so on. Anything that we can create in terms of a digital file, a PDF, or a DICOM file, these VNAs will store. And that's really their differentiator from the PACS. As hospitals really struggle to maintain and the cost for managing these PACS and VNA solutions continued, what we've seen, and I've seen this basically in the last 3 years, is more and more companies get into the business of moving the storage of images from the local infrastructure in the hospital to the cloud. And what that's providing for the healthcare institutions is lower cost storage. It's obviously simplifying the task of maintaining the hardware, maintaining all the software, and where they just simply need to do is make sure that the images can get pushed from the local site up to the cloud, or in some cases, some manufacturers are actually bringing the cloud into the hospital's IT infrastructure and hosting a private cloud right there in the hospital's data center. And you can see, this list just a few years ago, 3 years ago, was 2 or 3 smaller vendors. But to have a company like AT&T, who's now providing a medical imaging solution, is very unique and something I didn't anticipate 8 years ago when I first started in the medical business. And for Dell to buy an archiving solution as well and provide that as a significant part of their offering to the healthcare industry was something I actually didn't anticipate. So now we're seeing more and more the telcos going, how do we play in this space? Because we know there's big data, and most of the healthcare institutions are already their customers because they need access to the internet for other facilities. That brings me to sort of the heart of what I want to talk about today is our project with AT&T. We started working with AT&T over a year ago, and I was actually surprised when we first started with them in the lack of their knowledge of actually how to deploy a cloud solution. And what I found is our small little company with 80 people was driving the technology strategy for AT&T and how it was going to bring their solution to market. They had already adopted a solution called Accuo, which was used for storing the medical imaging data, and what they were missing is the actual heart of it is how do you actually display the images out securely to the users back at the hospital. And that's what we brought to the table with our Resolution MD technology. As I said, it was really our first attempt at providing a cloud solution, and we learned quite a bit. And there were things that we hadn't anticipated when we first started, and things that we're still building very aggressively in our software to make sure that we can continue to provide a very robust solution to the market. And the first is user login. Obviously people, we take it for granted, but when we actually have to integrate our component into the AT&T cloud infrastructure, that all of a sudden that becomes a key part of the infrastructure. And I'm sure most of you have heard of that healthcare is regulated. We have to control access. We have to not only control access, but we also have to record it. And so in our software, we had to add better support for logging to be HIPAA compliant. That's the regulatory in the US, which requires that we identify and log who accesses the system, and only who accesses, but what patient data they see and what they did with that patient data. In our case, it's what physicians log in and see what patient's images, and did they do a 2D, 3D reconstruction or what with that data. Not only that, the other thing we didn't anticipate with AT&T is that they didn't want to touch the healthcare side of the solution in terms of visualization part, because it's regulated by the FDA. And so they said, we will not bring your solution into our cloud unless you guys maintain that. And that provided a whole other set of problems, which I'll talk about in a moment. And the other thing which I wasn't prepared for is that they wanted our server and our solution to scale across multiple tenants. And we had, in the past, only deployed solutions that were site-specific. And so we moved to the cloud. We had to add more features into our product to support multi-tenant. So I'll talk a little bit more about those in a moment. Here's, at a very high level, how the system works. So you have a scanner at the hospital here, and that scanner, once it captures and the operator finishes basically creating an image set, it sends that to PACS, and the PACS is in a local hospital. As part of that PACS, they have what we call an edge device, and that device is responsible for taking the image from the hospital and sending it to the AT&T cloud, and they'll store that in the Accuo VNA. It actually goes directly to another device on the Accuo side, which listens for the edge device to send it data. And when that data is transmitted from the hospital to the cloud, it's encrypted by the edge device and then sent securely through a private VPN to the cloud. So every hospital that participates in this scenario uses a private VPN. And so once the data is there, then a user can access it from their mobile device, from an iPad, iPhone, Android device, or from a web browser. And they come into the cloud and hit the Resolution MD server. As I talked about authentication, we use LDAP to connect back to the hospital over, again, a secure VPN, because we don't want the hospital to have to configure two user databases, one for local use and one for cloud use, so that we piggyback through the private VPN back to the hospital, check against their LDAP to make sure the user's got the right credentials, and then bring that back through. In terms of multi-tenant, the same thing. We had to make sure that when, I'll go back to this diagram, if we just have one hospital, this is a fairly straightforward solution, something we can easily deploy. But when you have multiple hospitals that are all sending data into the AccuO VNA, when we bring that data back out, we need to make sure that a physician only accesses the data that they have permission to access. And so we added multi-tenant capabilities in. So a user, when he comes in, has to specify a specific URL that will identify what hospital's data they want to access. And once we know that URL that they're using, we can then figure out which LDAP to connect back to. We can know what configuration to connect into the AccuO VNA, which will tell us which set of data that user can access. And that's how we basically control the multi-tenant capability. And the other thing we had to add into our infrastructure was the ability for the hospital to only see their log entries that were appropriate to them. And again, that was not something we hadn't thought about before, because we hadn't thought about cloud when we first built the system. And we aggressively added that in to make sure that we could deliver on this solution. I mentioned earlier on that AT&T didn't want to take the solution from us unless we maintained it ourselves. And that brought a whole bunch of other issues into the equation. First of all, there was a huge security requirement they call scissor, which we had to meet. Now, just to get the contract, we had to review those requirements, which ended up being about a 4-month process, and make sure that we could meet those requirements. One of the key aspects of us being able to administer the system is we had to guarantee that we would securely log into their system. And what that meant was we had to create a new set of infrastructure, which we didn't have, that would guarantee that we could control who had access to the AT&T cloud. So if the bottom there is the IDC, that's the AT&T data center, that's where our product servers were, where we had to go to install software, control access, monitor logs, and make sure we had the latest version of the software on. We could only connect to that through a secure VPN, but that VPN could only be accessed from a secure site ourselves. So in Seattle, we created, we had a data center there, we created a secure access into the data center for AT&T. So we have a VPN that we access from the Calgary Scientific office into our Seattle data center. That VPN allows us to access a local administrative machine where we control access of who can control that. There's only 3 or 4 people from Calgary Scientific who can access that computer. And from there, we then tunnel again through the AT&T VPN into the product servers. So in one of the previous sessions earlier, we talked about security and trusting the vendors. Well, AT&T puts a big burden on Calgary Scientific to make sure that we control access into the system, because they need to guarantee a certain SLA to their customers as well. So this was a very costly venture for us in terms of getting this infrastructure set up. And now that we have it set up, we're going to leverage it for a lot of other businesses that we're doing. Adding mobility into the piece was obviously one of the key things we added because the data was in the cloud, we had to ensure that people get access to it from anywhere. And so we brought Resolution MD, which allows a user to connect through SSL into the data center and see their images on a web device or on a mobile device. And one of the things I liked about working with AT&T is that they control the network. And so when people ask us about, well, how secure is your network? Well, AT&T controls all of the aspects of the network. So they can see if there's any man-in-the-middle attacks. They can control and create an APN for someone to get better performance, better security. So this partnership with AT&T has solved a lot of problems for us in terms of the things that other people expected us to do. Now we just pass the buck to AT&T. What's interesting is that our business is not just in North America, and with a lot of the partners like General Electric and Siemens and so on. These are global partners, and that's taken us to other parts of the world. I was in Japan just about 3 weeks ago, and one of the things that we take for granted here is wireless. I see everybody's kind of logged in, they got wireless going, no problem. In Japan, a country that we expect to be very advanced in technology, the wireless isn't anywhere. You go to a Starbucks, wireless isn't there. You go to a meeting room with a partner, there's no wireless. How do you demo your mobile solution when wireless isn't there? So, they're not thinking about cloud right now, and I found it very interesting that North America was seemed to be much further advanced than Japan. It's also taken me to China, and with China, this data problem becomes even bigger. And this is something that we're working with some of our partners to bring solutions into China to ensure that they can get access to mobility and provide better healthcare to their citizens. So when you look at the number of hospitals, there's 80,000 hospitals in China, 80,000. And there's a big initiative right now in China to improve the quality of healthcare, now especially in the rural areas. So bringing imaging technology to the rural areas and bringing diagnostic capability through the cloud to those rural clinics. And so when you look at that many hospitals and how much volume they can create, it's a big, big problem. And we see that as a big, big opportunity. So as a wrap up, I think certainly our company had to mature quite a bit when it comes to the cloud and understanding how medical imaging could have real value, and our technology could really support what we see as a very emerging trend. Mobility and cloud are two of the big things that are affecting healthcare and healthcare imaging. And what we see, as I mentioned earlier, a lot of new companies coming to market. We're talking to more and more companies who are coming to us going, okay, we see what you've done with AT&T and others. How do you help us get there? Because we know that this problem is going to get bigger and bigger. And the information is getting easier. The technology is getting better and better understood. And I think you're going to see a lot more commercial solutions to medical imaging and also to bringing the whole healthcare record together as everything can move to cloud. So with that, we'll open up to questions.
Thank you. Any questions from the floor?
Your AT&T example is very interesting because your model seems to lend itself to a privatized health situation. Can you touch a little bit on your successes here in Alberta, or maybe lack of success here in Alberta, and maybe what you can see, what it's going to take for Alberta to move in this direction?
So I wish I had more success in Alberta, because it seems that companies really struggle to be successful in their own backyard. In Alberta, the government actually made an initiative with the Netcare portal to bring, to consolidate medical imaging into three zones. I'm not sure if they got down to 2 now, but they had a zone that you probably know, right? Okay. So they got down to 2 or 3 where all the data gets pushed into a repository that can be accessed through the Netcare portal. And I'm not sure, like I was aware of it 3 years ago in terms of where it was. I'm not sure exactly where it's gone. We've been focusing through our partners on a global basis, but certainly as our technology matures, I would like to see us be more successful in our backyard.
You mentioned your last slide that information is more and more available, which of course is great if you want it.
Yeah.
Of course it's bad if you want it.
Yeah.
So I'm wondering, I had this example before of doctors, medical doctors faxing health records.
Yeah.
So right now what you're describing is about information that is probably even more valuable than a health record or somebody else's health record. How concerned are people in your business about keeping information private? So you just evoke VPN and say, okay, that's safe per definition. That may not be the case. Is this something people think about, or is it something you hear for the first time?
Well, I think a lot of patients don't think a lot about it when they go in, right? Someone goes in and they have an issue, a broken bone, or more importantly, where this comes into play is some kind of major disease where you have someone else that you need to collaborate with. I think that tends to be what people are more focused on. I want to make sure that my data will get to the right person so I can get the right treatment. And that's the problem we need to solve. Certainly people are concerned about if their medical imaging gets out, especially if they had a condition that they want other people to know about. And so they certainly expect us as a vendor, and as AT&T as a vendor, that will keep their data secure, that will make sure that we're compliant with the healthcare acts and the regulatory provisions that keep their data secure. And if we're not, it's really, it's our bad, and there's real fines that we can suffer, millions of dollars of fines that our company can be liable for if we, through our technology or through our error, expose people's private data. So, I think it's definitely a concern, and it's an obligation on our part to make sure that it gets addressed. Do we have it 100% nailed? Like, you mentioned earlier that, every encryption method has been hacked. Well, one of the key things that I think about the information we contain is it's very time sensitive. And if someone finds out about it at some point in the future, I think the liability decreases over time.
Like DNS data?
Pardon me?
Like DNS data?
DNS data?
Yeah. Genomic data?
Yeah. I don't know, I think
that is not
I think that's a different,
long-term.
I agree with you on that one, that's a different, and we don't deal with that right now. And certainly, if I was dealing with that one, I'd want to spend a lot more time and make sure I've got some much better answers in terms of managing that data, for sure.
So I was interested, you were saying that AT&T wanted you to run the service, and you said there were some regulations they rather you dealt with. I just wondered what the implication to you as a company of you having to deal with something that AT&T didn't want to deal with is.
Yeah, so because our software is FDA cleared, they didn't want to take on the liability if something happened. Someone made a diagnosis with our software in a way that they made an error, right? And so they make sure that, assure you the data servers, we have access to the data servers and they don't touch them. So what that did for us is it really raised our awareness of security, because I didn't have a security policy internally, right? At 8 years we've been running, from zero to where we are today, and I didn't think about security very much. And so it really made us stop and think. I had to make a decision, did I want to invest in that or not? And now I have on board a security person, that's his job, is to manage our security. And it was really a good timing, because as I looked at us going to China, obviously we're concerned about our IP, we're concerned about people who start to know about us getting in to our walls, and having a security person on board makes me feel a little uncomfortable. I still stay awake at night thinking about it, but it at least makes me feel a little more comfortable.
Yeah, so I might be reading it wrong, but it almost sounds like AT&T forced you to take on all the risk. And I'm wondering, if you did it again, would you look into a way of sharing the risk a bit more?
Well, when you're a small company and they're a big gorilla, you don't really get a choice. So yeah, we looked at every angle. At first we said no. We said, we're not doing it. They said, okay, we're going to go talk to Unity. And we said, okay, hang on a second, maybe we'll reconsider. And then we said, well, what if we went through every angle. As I told you, it was at least a 4-month process. And we had our legal battle with their legal about liability and all that stuff. And basically I got to a point where I felt comfortable that the business outweighed the risk that we went after. Yeah. It was a very, very tough negotiation, and we almost walked away several times. But at the end of the day, they're a big company with a lot of feet on the street, and more importantly, as I said, they own the network, and they're going to be successful in this space. So better to tie your horse there.
Pierre, a question that I have, and this is looking at what I interpret from your slides around the security being primarily the transport, so VPN connections, SSLs. Did you look at, or would you consider in the future that this actually become more of a encrypted at the data level storage space and decrypted per client per request versus the current implementation?
Yeah, it's actually, in the earlier security sessions, I was thinking a little bit more about that. Right now, Accio is responsible for making sure that it's secure and for the transmission from the source to the cloud. But we do decrypt it in the server. And we do that because of the nature of our technology. We encrypt it there so our servers can process it and provide a rendered view back to the customer. So in some cases, I don't know how we would keep it totally unencrypted. We do just do it in memory, we don't ever put it on disk, so it's unencrypted in memory on the server, which should be safe. But then we re-encrypt it again and send it down in another format when we display the results to the user.
Now, myself not being as paranoid as I should be, I want my information out to the public, but anonymous, my health record information. Is that something that's coming, or is that we'll completely ignore it? There's too much liability. It's a risk to take on the FDA.
Well, different groups have tried to take your personal data and store it, right? Google's tried it, Microsoft has tried it, and no one's really been successful yet. I think people still are. I think there's 2 issues. One, people are still concerned about giving it to somebody else, especially to Google or to Microsoft. And the other more practical thing is most of the clinics that you work at, or that you go visit, aren't set up to send it someplace. So they're set up to give it to you on a CD, or to not give it to you at all, right? How many times have you walked out of the clinic and not had anything to take with you? I think that's probably the more practical reason why it'll be a while before it happens.
I have one more, and I'm not sure to whom I'm asking that, because you may not be the right person, maybe there's somebody here. So often, practices are simply determined by legal standards. You have to do it, you do it. You don't have to do it, you don't do it. Now, what we see in this whole field here is an extremely fast development which is pushed through technological capabilities. How do legal standards follow there? Are people looking into that? Are there more, are standards changing? Are there more regulations coming up because people realize there is risk at various pieces?
Yeah, I think it's slowly keeping up. I'll give you an example. When mobile devices first came out, the FDA did not know what to do. They didn't know if you could do diagnosis on a mobile device or not. And basically, we spent 2 years working with them, educating them in terms of what our studies showed. And as a result, they came back with a white paper and basically a in-practice paper of how companies who want to get cleared on mobile devices should operate. And so I think at least in healthcare, where we know there's regulations that we need to follow, we try to bring the regulatory bodies on board with us, especially if we're ahead, like we did with mobility. But you're right, if it wasn't there, we would basically try to move as aggressively forward as we can, because we're always trying to innovate and show that we're leaders, and that doesn't always mean that the regulatory part can keep up.
Here, thank you very much. I was on that regulatory one. I was in a meeting with an unnamed uranium mining organization, and their IT security people said their policy was that you're not allowed to bring phones on site that have cameras in. And the gentleman telling me this has an iPhone. And I look at it and I go, it's kind of hypocritical, isn't it? He goes, no. This is a camera that has a phone function. Compliance. Yeah, I told you when you came here that this is the session where the rubber meets the road, and we've heard a tremendous number of real-world challenges and huge benefits as well. Tyler and Saul, thank you very much for sharing from your side the experiences and the huge successes. Looking forward to hearing more from that. Carolyn, thank you very much as well for sharing from your side. And like I said, as a parent, I really appreciate the work you're doing, because it's a tough scenario from the patient family side. So that's a huge plus. And Pierre, of course, you're leading some positive stuff here. I truly appreciate it. Thank you all for attending. This is the third last session of the day. The next session is a light lunch in the foyer, which I encourage you all to join us, and plenary right after. So again, all the presenters, thank you very much, and have a great day.
Is our team coming to, so it's just at 2 hospitals right now? Okay. Is it coming to Alberta?
Hi, how are you?
Okay, well, I'm about to be a parent of twins. We've got to 33 weeks. And we're trying to hit 37. We'll see. So my wife's an OT, so she deals 100% of her caseload is the consequences of what went wrong in neonatal care. It's good, yeah. So we're close to brief successful. Yeah. This is a computer scientist. How do you end up doing this? Is very, very. What?
I met a neonatologist.
Okay.
This research showing in
What kind
Yeah, I mean, so, for example, we're getting, whenever ultrasound doesn't sort of give you enough information on the breathing of the babies, they're hooking us up to the artificial stirrup, which goes for